Okay, 6.4. Now, so now, 6.4 is exactly talking about this situation. This situation. If I have my x following a normal distribution, my x bar naturally should follow a normal distribution. That's all we're saying. Follow? And x bar is x1 plus x2 plus x3 divided by 3, right? Then the sample sum is x1 plus x2 plus x3 without the divided by 3 also follows a normal distribution. That's all we're saying. Quite simple, Oh. So this box is talking about that. That's all. And what is the mean and variance? We have done it earlier in 6.3. What we are saying is if x has a mean and standard deviation, x bar should have the same mean, but the variance is sigma squared divided by n. Follow? Depends on what is your n. Correct? Then the sample sum should have this mean and should have this standard variance. Okay, let's be more concrete. Let's use example. Example 1. The heights of a population are assumed to follow a normal distribution with mean 1.64, standard deviation 0.205. Can I have attention, please? So it's not difficult to write this statement. X follows a normal distribution, mean and variance. Define. A random sample of 80 people is taken. So each time you're going to take 80. Take 80, correct? The 80 people, when you take and then take the mean of the sample means the mean of the sample of 80 people, Or the sample of 80 people we're talking about. So this is talking about the sample mean, and we let it x bar. It is a distribution. It's not constant. Because each time you take 80, you get a different value. It is a distribution. What is the mean and standard deviation, or rather mean and variance? Let's practice. Before we run down mean and variance, let x bar be x1 plus x2 plus x3 all the way to x80 divided by 80. Correct? So from above, the result is quite obvious that if x is normal, x bar should be normal. Correct? If x is normal, I repeat, x bar should be normal. What is the mean? It should take on the same mean. What is the variance? It cannot be the same. It should be variance of x divided by 80. Follow? This is the part that we want to highlight. After you get these numerical values, the calculation is very easy. Correct? Your favorite, put into a calculator. But be very careful when you put into the calculator. This is variance. You don't enter variance to your GC, you enter 0.205 divided by root 80. This is the square root stat. Follow? Follow. Okay, so come, somebody help me. Answer. 0. Sharp. Hey, you all like to press calculator, right? Press. Lazy. 0. What? 1. Then next number, higher or lower? Higher or lower? 4. Very good, thank you. Next. Yeah, don't waste time lah. You're trying to. Can. Big example 2. Example 2, a machine produces cylindrical rods whose diameter are normally distributed. So now the diameter are normally distributed with mean 1, standard deviation 0.01. So if I were you, I will just define this right away and then write this. Correct? Diameters are normally distributed. Diameters are normally define properly. Define it. Mean 1, standard deviation. The only problem now is in the question, they want to find out what is the probability that the mean of their radius, not diameter, you can be very careful, is less than 0.4. So, if you are interested in radius, then got to be careful because we want radius. So I let R. If diameters are normally distributed, then the radius, which is actually diameter divided by 2, this one no need me to teach you lah. Should also be normally distributed. Correct? R is 0.5 d. What is the expected value of R? What's the mean of R? Must be half times expected value of D, which is 0.5. Correct? Quite obvious, huh? Next. What is its variance? Now we have half D, right? Variance of R must be half square variance of D, right? Follow? Okay, we call that half square variance of D. So must be zero, 0 to 5. 4 zeros. This is 0.01. Better write properly. Okay? Not difficult. So now we can safely say that R has this distribution. Yes? Yes? Okay? Now what do we want? We want the probability that R bar, the mean of the radii. How many? There means how many? The mean of there means all the 6 rods. Correct? You want R bar, and R bar is lazy to write. R bar is this. Correct? Mean of 6 rods. Radii of 6 rods. I'm quite sure you are able to work this out quite fast. If R has this mean, I use it to point at 0.5, not point at no, because my index finger is injured so I use if R has a mean of 0.5, R bar should have the same mean 0.5. Correct? And what is its variance? Variance must be 0.00. Why? Like choir, the S there. Okay. Divide by what? Divide by n, divide by 80. Oh no, sorry, 6. That's your 6. Alright? 0.0025. Then this one, simple calculator work. Don't waste time. Just key into a GC. Done. Okay. This is the part that just now failed big time. Now this time should be okay, I hope. Part 2. Find the probability that the sum of the radii, this time you want sum. That means you want R1 plus R2 plus R3 plus R4 plus R5 plus R6. No need to divide by 6. So T is this. And if R follows a normal distribution, T should also follow a normal distribution. What is its mean? It must be 6 times of 0.5. Make sense? The mean must be 6 times of the mean of R. And what is its variance? Must also be 6 times of 0.0000025. Once you know this, you key into a GC, find what is the probability that is less than 2.99. Easy lah. Just like that. Can. Good. I think I'm going faster than what I did just now.